what are we doing here?
Okay, so we're assembling a 4 series of lithium ion cells, and we're making a 12-volt battery, so 12.8 nominal voltage to run after the DC-DC in your ATV. So these will have a 100 amp battery sort of amount that it can be used, and I have an output rating of about 5C, which will make it 500 amp output, which is way more than you need. But it'll be a 12-volt system. Everything runs off the vehicle. That's 12 volt. Will be running through this battery to act as like a capacitor, and you can run multiple machinery off the vehicle at the same time. So I've already put the studs in, as you can see. These battery cells have sort of holes to put the studs in. So,
right.
I've got measured.
Are the holes tapped already?
Yeah, so the holes are tapped with an M6 thread, which makes this breaking point where they're laser welded to each other a lot safer than having a stud just hanging out of the battery.
Yeah.
I've had to measure the bus bars, measure this distance, and then combine that to get the height of these, plus a washer, spring washer, and a lock nut with 2 threads exposed.
Right.
To be able to get a sufficient tight seal and to eliminate any arcing after installation. That's another reason I put on this the conductive grease to fill up a little bit of the void caused by slots in the piece. We're using these bus bars with a braided line because they're rated to about a 500 amp and they're quite heavy duty. And we basically don't want to be messing with anything or overheating them, so we go over spec. So I'll just start assembling them in series, which is a lot simpler and a lot safer. So we're just going to follow the series, so we're starting here with the negative terminal, go through the positive, then to the next negative.
How do you know which one's negative and which one's positive? Is it written on the battery cell, or is it a colour code or something?
So there's usually a symbol right on the top. This one is really difficult to see. There's a positive and a negative symbol. It's really difficult to see, but I looked under a microscope and I figured out which one had the copper, which is generally the negative, and the positive is generally aluminium. So it's a rule of thumb, but always best to check. So the last one in series. Just give it a bit of space because there'll be a carbon sheet going in between these. So
and what you were saying before, it's really important to do it sequentially, put those connectors in sequentially from one end to the other, because otherwise you'll get an arcing in the middle there.
If you don't put them in series, you'll get a higher voltage, higher amperage arc in here, and that can cause pitting, which again will cause resistance, which will make your battery less efficient.
Right.
So a particular way to be able to make it the most efficient. Then we've got the BMS, or the battery management system there. So we have the one that goes to the battery, and then the power connector, which goes to your charger and your output. We have a BMS module there, which Bluetooth to your phone, which we'll go through later. But they need to connect to the battery, so we start with these lines. And we always start with the negative first for a similar reason. If this is plugged in and you start with the positive first and negative connect last, you can either blow the wire or blow the internals on this, because the MOSFETs will be reverse current. So we always start with the battery wires disconnected. We start on the negative pole, which we demonstrated earlier has a negative symbol, is usually copper. Go to the next in the line, or string, depending on where you're from. Go to the positive terminal, and then next in the string again to the next positive terminal.
And you were saying before that these individual batteries you're putting together in series, you've already charged them.
Yeah, so I've balance charged them to 3.5 volt, which is just below top voltage. So they've been charging for 3 days on a very low 2 amps current.
Right. And this is always important for the initial when you're building a battery assembly, this is always important. You know, you wouldn't just put them all together flat and then try and charge the whole thing.
No, it has been done before. It's definitely not.
It's not a good way to do it.
No, it's not the most effective, that's for sure.
Yeah.
The batteries won't, depending on your BMS, if you don't have a good quality BMS, your batteries won't balance after that, so you have a lower cell the whole time. So, but these daily ones I use are quite efficient, quite smart, so they wouldn't do that, so I can actually charge it when it's built, but I can't test the resistance of the cells.
Okay.
So I can't marry them with the best resistance into parallel sets. So, for example, I think one of them had 6 milliohm, the other had 7 milliohm, so they're within a tolerance of a milliohm. None of this probably makes a lot of sense, but it's sort of...
It will one day.
It will, eventually, yeah, exactly.
To people, yeah.
So then, after all this, the method I'm using is the bus bars on the bottom, the battery sense wires or temp wires on the things, and I use a washer. I just realised I got the wrong nut. So just a normal everyday washer. Just putting them on each one. And because I've used the stud instead of the bolt or etc., this makes setting up A, a lot easier, and B, I'm also next in line I'm putting on a spring washer.
Yep.
So again, just to hold that terminal as tight as it can.
How tight have you screwed those studs into the terminal?
So these are just hand tight.
Right.
For the time being. They will go up to 6 Newton meters.
Yeah, but really it's just your main contact is the top of the terminal, the flush top of the terminal, really.
Yeah, so all it's doing is pulling it into that terminal.
Yeah, right.
The plate there.
And when you tighten those bolts up, those studs up, they'll tighten anyway.
Yeah. Against
themselves.
So that's the plan of using the studs, and they're also the studs I've bought have a Allen key terminal in
the top there.
In the top,
cool.
So you do this sort of system to tighten it, so you're not putting as much pressure on the actual terminal. Because if you snap one of those off, they're laser welded, so it's extremely difficult to get it repaired.
Right.
And the battery cells are a couple of $100 each.
Yeah.
So you don't want to be doing that too many times. From experience, unfortunately. So just going through, putting on all the...
Yeah, right. So you've got lock nuts as well.
So lock nuts as well. So you're going ridiculously over the top, which is not really what you need. It's not the basic plan, but it's my plan.
Yeah.
I find it the safest way. And the whole time I haven't touched two terminals at the same time.
Yeah.
But the other way to do this is to wear workman gloves or rubber gloves or something.
I mean, out of respect for Polaris, we did this. We mentioned this before, didn't we? We will add something shit to this rebuild, just as a bit of a tip of the hat.
Yeah, exactly.
To the original vehicle.
Yes, we'll try to. That's for sure. That's why you don't touch terminals.
Okay.
That's why you use carbon tools where you can.
Right. Did I distract you?
Yeah, sorry, no problem. So
anyway, bit of drama.
Bit of drama, makes it exciting. So normally you'd be assembling this in a box already.
Yeah.
So
what did you just touch then?
So as I touched this positive terminal, I went back and touched this negative terminal. So it was only 6 volts going through it, and because my hand was on the end of the spanner, it didn't actually arc my hand, it arced between each other.
Right, well we're not really worried about your hand, I'm just worried about those, hundreds of dollars worth of batteries there.
Yeah, of course. Yeah. I'm not that worried about my hand either, so don't worry about it. And then we connect the battery side.
Yeah.
It's usually marked with a B+, depending on where you're getting your BMSs from. Put another washer on, another spring washer. And then because I'm going to be removing this and putting it into a different box, it's just easier to see like this. I'll be just using a normal nut on these sections I'm going to pull apart.
So this is my 12-volt accessory unit, this one. So that little BMS thingy, is that the thing for the whole machine? Or is each pack got one of those?
So
How does this work?
when you buy a 48 volt pack online from Giants or whatever,
Right.
they will each have one of these.
Oh, okay.
But the way I'm doing it is I'm putting 4 cells in parallel, so it'll be look like this, but they'll be in parallel,
Right.
not in series. So we have double the amount of bus bars, and that will. So each cell grouping of 4 will be 3.2 volt nominal, and then I've used a BMS very similar to this, a lot bigger, with I think 16 wires coming out, so 16 series, and that I'll wire individually each group of cells to.
Right.
So 4 cells will be charged 3.2 volts. The risk of this is that you can actually damage one of the cells out of all of them, because the chemistry is exactly the same. And then that'll cause a fault with the whole cell, the whole run. But using these batteries, that can happen, but it'll just run through it. It won't actually cause us a fault, like if it was nickel metal cobalt or something like that, which is my usual one I use. So I just realised I've got the wrong tightening down tool here in my hand. Put the other one. That's right. So, but in this sort of area, I would usually use a socket on the end of a screwdriver type scenario, like this over there, which stops the problem that we had before.
Yes.
Where it's arcing. So that would be the next step.
That's all right.
And just before I go do tighten them down, I'll be picking these up and just popping a little bit more conductive grease into that gap there, which you can do before you put them all on, but either way doesn't matter. And then the final one would be the positive terminal, which I've swaged up and put heat shrink over the joint. So that's a similar gauge cable to the one that's coming out here, so you have your positive and negative there.
Yep.
This BMS is going to sit something like that. The plug will go in when I've tightened all the batteries so we don't loosen them. Once I find the right tool, and then we can have 12 volts coming out and going in, which is one of the bonuses of these. Is only 2 wires, so out and in is on the same wire. The cheaper BMSs generally have 3 wires, so you've got one for out, one for in. And there's nothing wrong with them. They're quite alright, a lot better than not having one. But I've used these in at least 8 projects or builds, and they've never had a problem with them. And with the Bluetooth module, you can control all the parameters on your phone.
Right. So, brilliant.
Yeah.
Right. Thank you.
No worries.
Excellent.